Welcome back, learners! In this video, we're going to do integration by parts. Integration by parts is a method or technique that we apply when we are integrating a product of two functions, such as this integral x sine x dx, where we will integrate the product of x and sine x with respect to x. The formula to be used for this is the integral u dv is equal to uv minus the integral v du, which means that in the given integration of the product of functions, we will identify the u part and the dv part. In this example, we can consider x as our u, while sine x dx is our dv. If you look at the formula, we will still be needing v and the du, because what we only have is the u. The du will come from differentiating u. And since we have identified x as our u, we just get its derivative and we'll find the du. Let's get the derivative with respect to x. That means we have du over dx is equal to derivative of x with respect to x is a1, right? And then if we multiply both sides by dx, there we can find the du, which is equal to 1 dx or just the dx. And then the v will come from integrating the dv. And since we have identified sine x dx as our dv, we just need to find the integration of both sides. Therefore, v is equal to, since according to the rule, the integral sine x dx is negative cosine x plus c, then the v that we will use is this part, negative cosine x plus, just the negative cosine x. Now we have complete details for use for our formula. We have u, we have v, and we also have du. Now let's do this. We have u, which is x, multiplied by v, which is negative cosine x, and then minus the integration of v, which is again negative cosine x, multiplied by du, which is dx. Then we just simplify this. We have equals negative x cosine x minus, we can actually bring out the negative part because that is our constant part here of the integration. That becomes plus the integral, now it's positive cosine x dx. Then simplifying this further, we have negative x cosine x plus the integral cosine x is positive sine x plus c, of course. And that is our final answer. And since the integration is the reverse of differentiation, then a way to check if your answer is correct is to get the derivative of your answer. Okay, so let's do this. As you can see, for our first term, we will apply the product rule of differentiation, where we get the derivative of the first term, the first factor, which is negative 1, multiplied by the second factor, plus the first factor multiplied by the derivative of the second factor, which is negative sine x. Then the derivative of positive sine x, which is positive cosine x, while the derivative of c, which is c is a constant, is 0. And then we simplify this. We have negative cosine x, and then negative and negative, that's plus x sine x. And then we have our plus cosine x. And as you can see, we can actually cancel the negative cosine x and positive cosine x, leaving us with only x sine x, which is this one, right? For our next example, let us take the integral x squared ln x dx. So for this one, let's identify our u. Let's use x squared as our u. And the dv, of course, will be the remaining part, which is ln x dx. So to find our du, let's get the derivative of u is equal to x squared. So we have du is equal to the derivative of x squared, which is 2x, and we can already write the dx here instead of doing the du over dx equals 2x and then multiplying both sides by dx like that. We can go directly to writing du equals and then just put the dx at the end part. And then to find the v, let's get the integral dv is equal to the integral ln x. So we have v is equal to, according to the rule of integration for ln, we have x ln x minus x plus c, where we only use this part for our v. Now we have the complete details. We have u, which is x squared. We have v, which is x ln x minus x. And we also have the du, which is 2x dx. So here we have substituted the details to our formula. Let us continue. We have, for this part, we can actually distribute the x squared to these two terms here. Therefore, we have x cubed ln x minus x cubed. And then, we can actually bring out this constant part here in front of the integral symbol. Therefore, we have a minus 2 and then integral x ln x minus x, and then here it's only x dx. And then we have x cubed ln x minus x cubed minus 2, and then here again we can distribute our x here to these two terms. Therefore, we have the integral x squared ln x minus x squared dx. And then we have x cubed ln x minus x cubed minus, again, another distribution here. We can distribute the 2 to both parts here. Therefore, we have minus 2 integral x squared ln x dx minus the minus 2 integral x squared dx. But oops, it actually has to be plus because it's negative 2 times the negative here. Okay, so let's continue. Between these two, what we can get is the last one, 2 integral x squared dx, right? Because as you can see, this is the same as the one that we are solving for. So they are similar terms that we can combine on the same side of the equal sign. So let's move on. We have equals x cubed ln x minus x cubed minus 2 integral x squared ln x dx plus 2, and the integration of x squared dx is x cubed over 3. Then we put the plus c at the end. And then now let us transpose this part to the left side. So we have the original one at the left side is the integral x squared ln x dx. Then the transposed one, that minus 2 there becomes plus 2 here, plus 2 integral x squared ln x dx equals the remaining terms here, which are x cubed ln x minus x cubed plus 2x cubed over 3 plus c. And then combining these two, we have 1 and a 2, so we have a total of 3. Right? So 3 integral x squared, let's just remove the parentheses, 3 integral x squared ln x dx is equal to x cubed ln x minus x cubed plus 2x cubed over 3 plus c. And if we divide both sides by 3, or if we multiply both sides by 1/3, which is the same thing, then we have the integral x squared ln x dx is, maybe let's write that a little lower. The integral x squared ln x dx is equal to, let's multiply every term by 1/3. So we have x cubed ln x over 3 minus x cubed over 3 plus, we have 2x cubed, 1/3 multiplied by 1/3. So 2x cubed over 3 times 1/3 is 2x cubed over 9 plus c. And that's it. But we can actually combine these two terms here since they are like terms, right? So we have our final answer as, does it fit here? Maybe let's write it here on this leftmost side. So we have equals x cubed ln x over 3 minus, we have equals x cubed ln x over 3. Let's write them both as over 9. So that means for x cubed over 3, we will multiply each part by 3 so that the denominator becomes 9 also. So we have minus 3x cubed over 9 plus 2x cubed over 9 plus c. Then our final answer is x cubed ln x over 3, just a minus 1x cubed only. So minus x cubed over 9 plus c. There is our final answer. So what can you say about this solution? It's a bit lengthy, right? There is actually a technique that we can use to make our solution a little shorter. That is the technique that I call the late method. So learners, what would you like to learn next? Comment below.